जी, Bismillahirrahmanirrahim. In the name of Allah, the most merciful, the most kind, we are going to conduct this session on PLSM. The nature of this session is that this is going to be a very sort of basic concept on PLSM. So ideally, what we should be talking about is that what is PLSM, for what kind of research is used, how is it different from other type of structural equation modeling, what is the objective of PLSM, and then what are the assumptions, how to specify the model, and then how to make measurement model and test it, how to make a structural model and test it, and then variance effect size and blindfolding, what these are, how to use them, and then lastly how to report it. So ideally, essentially what the purpose of this session is to create a baseline of what is structural equation modeling in terms of partial least square approach, and then maybe moving forward in other session we may be talking about some other concepts a little more advanced or a little more intermediate level, but this session will be talking about something very basic. Nonetheless, this session is important because we'll be talking about the theory, we'll be talking about the reasoning, we'll be talking about what are the objectives of using it, right? Why is it better? Why it is better than CBSM, which is covariance based structural equation modeling. Okay. So I guess that we all are set almost with the Smart PLS. Everybody has been able to set it up. Okay. Number one, like I said, something very basic. Number one, we need to know what is a construct. What is a construct? Probably many of us, just when we started our research, probably we weren't much clear about it. But now it's time that we get further clarity on it, and we need to. Once we are clear about it, then we'll be able to understand that why do we actually use PLSM, which essentially means there are many type of data, there are many type of environment that you should not be using PLSM, right? So the basics of PLSM is a construct. If you have a construct like a type of construct where you want to, especially if you want to measure a concept, right? For example, motivation, for example, loyalty, satisfaction. This is where PLSM is specifically useful. That doesn't mean you can't use it for other type of data, but for example, if your interest is secondary research, this is where secondary data, this is where finance or probably economics, then most probably PLSM is not a very smart choice. You should not be using. So what type of construct we're talking about? We're talking about actually constructs such as motivation, visual activity, justice, problem solving ability. These are the type of things, these are concepts. These are not something, these are not things that exist anywhere. You cannot tap on them. These are not tangible things. These are just concepts, right? We also call these concepts variables. So essentially there is no difference between variable and construct. It's just a two different way of seeing things, the same things, right? When we say a variable, in research, a variable is any constant that possesses some value, and it has some levels. That means it has some dimension. It has some variation. That means loyalty may be higher and lower, right? So if you have this is where we are talking about variable. So if we talk about variable or we talk about construct, actually it's the same thing. It's just two way of saying the same things. Okay. Now there are many variety of there's a huge variety of variables, such as we have dichotomous variable, right? Gender, male, female. You may want to call it categorical variable. Some people call the same one as categorical variable. Then polytomous variable. And then we have continuous variable, then we have observed variable, then we have latent variable. In order to understand how structural equational modeling works, we need to know about these types of variable. We need to know these type of variable. And probably most important is continuous variable. For example, you have We have Likert scale questionnaire where for one item respondent response on various scale. Essentially, that's a continuous variable. We also call it, in SPSS we call it a scale, but actually it's a continuous scale. And then categorical variable, any type of category, anything, you could be a manager, you could be a higher manager, you could be a lower manager. That's a categorical, variable. We can test them in structural equation modeling, but there is a theory we have to follow. There is some type of caution that we need to be careful about them. And probably most important type of variable that we need to know in structural equation modeling is the latent variable. And I assume many of you already know what you mean by latent variable.
Sir, but I need more explanation.
We will talk about that.
CFA
Yes, explanation is coming here. Let's just wait, right? Okay. So, likewise, we need to know what is independent variable. We need to know dependent variable, mediating variable, moderating variable. And what I've tried to do is here that I've tried to put all these examples are there. So, but like I said, for me, in my opinion, the most important is latent variable. We need to understand what is a latent variable. We need to understand, how the abstraction is done. Okay, let's move forward here. Now, just take a look at what is happening here. On the right side, you see a conventional way of collecting data through a questionnaire, and you see here 2 statements. And for each statement, there are 5 levels of agreement, right? You may disagree or you may agree. Essentially, what we're doing is that what we're doing here is that we believe that there are many type of concepts that cannot be measured directly. And any concept, any construct that cannot be measured directly, we call it latent construct, right? That means it's hidden, it's not open. Now, so then how do we measure actually? That's the real question. We measured by these items, right? The items, we also call it indicators, and these indicators are actually called observed variable. And notice the shape of observed variable and the latent variable. This is very important. This is to identify what is the type of, especially in smart PLS and PLS-SEM, to identify what type of variable is that there is a shape involved. There's a shape to it. So a construct are built from the logical combination of a number of observable or unobservable concept, right? And we'll talk about what are unobservable concepts. Essentially, we're referring to dimensions here, right? So any concept, for example, loyalty, for example, motivation, for example, status. These are the concepts that we cannot actually. The idea is that we cannot capture them. We cannot measure them directly. There's no way. Right? Until today, there is no theory exists that says that you can measure directly. Rather, there's an indirect method. Method which we call items or indicator of the question. That means I know what you're doing. I can take your recipient on a certain action, and I believe that if these 5 actions are reliable enough or significant enough, that means this certain concept is taking place, right? So if I want to know somebody is satisfied, I'll give them 5 statements. And if they give me, they agree to all those statements, I can assume that the satisfaction is there. So I cannot measure satisfaction since it's a latent variable. Just like social status. Yeah, but I can measure observed variable, which are the indicator. Right? For example, somebody say, well, I want to know how much happy somebody is, and they say, well, when I get up in the morning, I feel great. Right? So because they're reporting I'm great, this is something we can measure. Now imagine in regression, were we doing the same? Do we do the same in regression? Actually, the theory is different. Even if we're doing, the theory is different.
No, we don't.
Right. The theory is different. How? Because in regression, these 5 items do not predict, rather do not signify social statum, rather that's a summation. There we actually just simply add an average. And regression is simply adding an average. It's different here. Here it's not adding these 5 items, whatever the response is, 2, 3, 4, and then adding them, taking average. Here is the variance. Here is the variance. The weighted variance score of all these 5 items, that tells us whether there's a social status, whether these 5 items can predict social status or not. So there's a difference, and hence we call it latent variable. We believe that the new theory says that when you sum scores, actually you think that's what the variable is. While we believe that's not the variable, these 5 items are not the variable. These 5 items are the observed variable for the latent variable that we want to measure. So if any item does not have enough variance, we believe that has no role in predicting or defining social status. In comparison, in regression, it doesn't matter whether you have 2 or 3, whatever your mark, everything counts to that. Everything counts to that. So that has a disadvantage of regression. So after the development of theory, after development of latent construct, they believe this is a better way of measuring any type of concept, especially in psychology, especially in business, HR. Whenever it comes to some type of abstraction of concept, this is a better way to abstract it. And this is the one of the major reasons we should be preferring PLS, any type of PLS.
Can we control latent variables? Like in CFA when we don't have
control, you're talking about control variable?
Yes, can we control latent variable for factor loadings to factor loading हमारी range में आ जाए, जैसे 0.3 से above अगर factor loading होती है तो वो अच्छी होती है इसकी.
It means how to improve it.
Yes, how to improve it.
We'll talk about when we go to measurement model. We'll talk about that.
लेकिन सर यहाँ मतलब how we can उसको किस तरह से डिस्कस किया जा सकता है latent variable को कि किस तरह से कंट्रोल होगा और किस तरह से वो
means how to improve the values of latent variable. Is that what?
Adding covariances, I know, but there is another method.
Because I'm not sure about your question. How to control? Control mean what? Control what?
Sir, actually,
improve the coefficient value, regression coefficient value. We'll talk about that when we go to measurement model. We'll talk about that. Okay, there are many methods. There's not one method. There are many methods to it, right? One simple method is just change the scale. Your scale doesn't capture what you're trying to capture. How many of us actually sit down and read each item of each of our construct? How many of us do? I'm telling you, in the beginning of my research paper, I didn't do that. Later on, I learned that this is where the problem lies. We don't read the item. We don't even read the observer, whether it's really capturing what it's supposed to capture, which converts into social status or not. We don't read that. I'm teaching a class in this semester, business research method, and probably 3 times in 3 different classes I've gone at length talking to them. Listen, you need to read each item, read that, closely assess, is it capturing the concept you want to capture through these 5 items, 3 items? And they don't read it. They just take it because the customer satisfaction has been used in that environment, so I'll use it. Just read it. Most probably this is not what you want to do. As a result, it will give you a wrong result.
The cultural relevance.
Not just the cultural relevance, it's the context, right? For example, let's talk about customer empowerment, right? Now, customer empowerment in sales, retail environment is quite different compared to in a service environment. A customer empowerment, somebody who's buying at any retail store, this type of customer, and a customer of a hospital, these are 2 different things. There's satisfaction, if you're measuring in the same way, well, anybody can come and question that, really, are you sure? Many this, okay, whose research is it? Your research or somebody who developed this skill? Not just the reliable, also the valid. Keep in mind, if it's not valid, there is no point of reliability. Is it doing what you're saying? Let's say you say happiness. I am measuring happiness, and according to her concept of happiness is completely different than your concept of happiness. Should you be taking her scale? This is where your question. This leads to invalid findings, right? Let me just complete it. Because there is no agreement on her concept of happiness and your concept of happiness. Why are you measuring your concept of happiness from her scale, even though her scale is measuring something else? This leads to invalid finding. This leads to, when it comes to discussion, you can't discuss it. Somebody reads your item and your discussion, you say, well, seems like you're quite confused. Your items are capturing something else, and you're talking about something else in discussion, completely different. You have no idea what you are doing.
So I can understand actually मेरी रिसर्च में मेरे साथ ऐसा हुआ भी कि मैंने एक स्कोपिंग का स्केल लिया 50 आइटम्स का, उसके अंदर डिफरेंट सब स्केल्स थे. जब मैंने उसका CFA किया तो CFA में सिर्फ 12 आइटम्स की फैक्टर लोडिंग एक्सेप्टेबल थी, बाकी सारे आइटम्स की जो फैक्टर लोडिंग थी वो बिल्कुल भी एक्सेप्टेबल रेंज में नहीं आ रही थी. तो वो बहुत ही ज़्यादा एक डिजास्टरस थिंग थी मेरे थीसिस में, जिसकी वजह से मेरी रिलायबिलिटी स्केल की बहुत लो गई. फिर मैंने वो सारे सब स्केल्स रिमूव किए.
Reliability is one area. The other, I am more concerned about validity, right? Your respondent's happiness is different than the her concept, and as a result, they say no, even though it should be yes. Why it's no? Because you use her concept. Her concept is completely different. This concept doesn't sit right with your respondent. That means your context is different. Their happiness is a little different than her. As a result, we need to read the items. Just because I'm not able to find the scale, well, I'm sorry, this is not a very good argument. That tells me like how casual I am about my research. Who will trust my results and my finding if it has this type of error that I don't even know what my items are measuring? Very simple. Read each item. Ask yourself, is it really what you are looking for? And the common concept is if let's say if there are five items for for your latent variable, and one item is out of what you're looking for, it doesn't sit well, but the four do, I would say let's take it if there is no other scale available. But let's say if 3 items of my variable are not what I'm looking for, this concept is completely different than what I actually am trying to measure, nonetheless it's called happiness. I wouldn't take it. I wouldn't take it. I'll find other ways. There are other ways. And write this down and I'll tell you what are the other ways. There are other ways to it. Right? Any question? Should we move forward? Okay. Now let's take a look what is happening here. Now still the latent variable is source credibility. And then source credibility has 3 more latent variables that we call dimensions. And then those dimensions, each of these dimension has observed variable. Right? In this case, actually dimensions themselves are latent variable. So you have one main latent variable, source credibility. Then you have expertise, objective, status, which is the dimension of source credibility. So each of this dimension is also measured through observed variable. If you look at this is what we do in our research. Many times we use dimensions, right? Actually, reality is that in regression, you just can't do it. Actually, you put everything together. You make them all one, right? I cannot predict how much expertise predicts source credibility in regression. Actually, you put them all together. Because you're summing them. I don't even know whether these 4 items of my how much these 4 items are actually contributing to source credibility, because I take them all together. I take them all same when I average them. Right? That is not happening here. They don't take average. They said weighted variance. They take weighted variance. Each item has its own weight. If you have more weight, then I'll contribute it.
As a whole,
we don't take it. We don't average it. But in regression, we average everything. Probably averaging. So that's any even linear regression, any regression, we actually do it. And that's another call a downside of regression. As a result, this is better. Theoretically, this is better. I can better understand. According to theory, my calculation is also according to theory. My quantitative analysis are accordingly. Otherwise, regression cannot do it, actually. Let's move forward. Okay, back? Yes. Formula? Where is formula? If you want to put, I'm sorry, if you like it this way, you're right. Actually, I just want to show you, our main, if your source credibility, our main concern, our main interest, and we have to measure it through 3 dimension, and each of the dimension is measured by the observed variable, right? If in any other case, probably somebody is measuring source credibility, directly by some observed variable according to their scale, according to that theory, according to the concept, right? We don't know. I've taken this scale. Okay, So first, regression data analysis techniques have been widely applied by social science research. We're talking about regression and many other things. However, for last 20 years, second generation techniques, have caught up, and because of the weaknesses of first generation techniques, some of the weaknesses I've already explained. These methods refer to structural equational modeling, enable researchers to incorporate unobservable variable measured indirectly or directly by indicator variable. They also facilitate accounting for measurement error in observed variable. So this is what we're talking about. First generation technique, cluster analysis, factor analysis, multi-dimension scaling. Second generation, PLSM. Primarily, it's all exploratory. First generation, confirmatory analysis of variance, logistic regression, multiple regression, and primarily for confirmatory second generation is CBSM modeling, confirmatory factor analysis. If you notice, they're clearly, and we'll be talking about in coming slide, they're clearly dividing PLSM and CBSM into two different categories. They're calling it second generation. These are advanced, these are better. But they're also saying it, actually there has to be a reason why you're doing it. If you're just looking for confirmation, we also call it model testing. Then CBSM is a better way of doing it, and there is a reason, we'll talk about that, common factor, right? But if you're looking for exploratory, you're looking for something new, you're doing something nobody has done it before, PLSM is far better approach for that. Nonetheless, PLSM is commonly used for model testing as well. It's very common. Actually, if you pick up, like I said, as far as my observation goes, 90% of the research I see that are using PLSM, those are actually confirmatory model testing. They're not doing something very new. They're doing something that people know it's just a new context, small variation they want to test, new question. That's about it. Same variable, same relationship. So what do you mean by covariance based CBSM and partial least square SEM? PLSM, also called PLS path modeling. So now as we move forward, we need to get ourselves familiar with the language of PLSM. We also call it PLS path modeling. PLSM actually or CBSM, they all are called PLS path modeling. Very simple, right? So very simple. When you mean a path modeling means wherever you have, let's say any variable that I take as a variable, not as a dimension, that's we call path modeling. And if I add latent variable to it, that means any dimension, and I said these dimension predict this latent variable, then we are calling it actually PLSM, structural equation modeling, because through simultaneous structural equations we are actually predicting that latent variable. Yeah. CBSM is primarily used to confirm or reject theories, a set of systematic relationship between multiple variables that can be tested empirically, right? Amos, we know Amos. This, she knows very well what Amos is. Common. Actually, it's a CBSM. That means it takes covariance. We know correlation. Yes. We all know correlation. Actually, there is not much difference between covariation and covariance. It's just when you try to standardize covariance, that becomes correlation. So what is happening is, let's say you have five variables that are predicting any variable, then they're predicting a dependent variable. In covariance, you actually take correlation of all those five variables. In comparison, in PLSM, it doesn't take the correlation. In other words, it doesn't take the covariance of the other predictor beside it. So you have five predictor, one dependent variable. Each predictor has its own variance. There is no covariance. There is no correlation. They don't calculate it. Because the idea is that the very simple idea, we take correlation for a theory that we know for a fact these five variables always go together. If this increases, this should increase as well. In comparison, PLS, because our purpose is to develop a theory, to enter a new area, we do not take this assumption that because this variable is increasing and this is helping us increase dependent variable, so the variable beside this, which is another predictor, this should also increase. We don't take any correlation. We don't take any covariance actually. It's purely variance, how much it explains the dependent variable. So this is the difference. In contrast, PLSM is primarily used to develop theories in exploratory research. It does this by focusing on explaining the variance in the dependent variable when examining the model, right? Okay, let's take a look at what is SEM. Is not one statistical technique. Another thing where we need to understand that it integrates a number of different multivariate techniques into one model fitting framework. It's an integration of measurement theory, very common in psychology. Ma'am, am I correct? Measurement theory. This comes from psychology, if I'm not wrong. Measurement theory was actually, the psychologists actually, they were the one who actually created or advanced it. Factor, latent variable, path analysis, regression, simultaneous equation. We actually in SEM, structural equation modeling, they have put together all these five theories, rather five type of analysis into one, and they're calling it structural equation modeling. As a result, they call it advanced. As a result, they call it better because you're taking help of many things. You're not just regression, very simple. You do two things only at two stages and done. It doesn't do it like this. It takes 5 different type of analysis. It believes that measurement theory should be doing where the measurement is required. Factor analysis should be doing where the factor is required. Path analysis should be doing where relationships are required, right? And likewise, simultaneous equation, that means all the predictor variables should be predicting the dependent variables simultaneously, not alone like we do in linear regression. You know, linear regression checks each path one by one, right? That's a difference. That's another difference. PLSM is a complex, multifaceted construct. You know, it specifies system of relationship rather than a dependent variable and a set of predictor. They're referring to here regression and many type of regression. Focus on indirect, mediated, as well as direct effects of variable on other variable. By the way, one of the major downside or demerit of regression is that regression actually itself is not able to test mediation and moderation unless you go towards some other advanced regression. Common, what you call OLS, ordinary least square method that I use, you know, you have used, that actually not able to test mediation and moderation, right? Rather you have to, let me just complete. Rather you have to do quite manually, or there's some add-on available, but there's a huge argument on that. Again, you're doing one by one. You're not.
We add process on the.
No, the process actually is PLSM. Is PLSM, right? It's not regression actually. Process allows you. Process is an add-on, right? It's an add-on in any SPSS, which allows you to, because SPSS doesn't come with this option. So somebody made a software actually. Hayes made this software, and he said that now within this you can just add it, and now you can do PLSM, you know, remaining in SPSS. I personally do not like it. It's even though it has some extra option, it doesn't have many options that, you know, this Smart PLS or Warp Plus offers. So I don't like actually PLS. My personal preference is not process. System. And for example, effect size, I don't think process offers effect size. I don't think it does. So I wouldn't go with that. But if there's a free almost free or student version available, so, you know, just imagine how much development they have made in Smart PLS. I personally think Smart PLS is far better than others. Even Warp Plus offers you a lot, but when it comes to using and simplifying, PLS is far better.
Can you say that now they have made a lot of changes in, they have improved the PLS, and now we can say one window shop, each and everything is available on this.
And keep in mind, they can't provide you one window experience unless they contact that developer, takes their consent, agreement with them, then they add that particular type of analysis in PLS, in Smart PLS. For example, PLS Predict. Right, the person who made it in 2016 probably wrote the first letter, PLS Predict, first study, and that got popular. The idea was older, just nobody had talked about it, and he said PLSM has this problem. Out of sample, what do you call, out of sample relationship you're not taking. You're doing just the same as regression does it. And then they went to him, and obviously they included PLS Predict. So you believe there's some legal work involved in it. You cannot take somebody's analysis using your software.
When you go for the presentation, main question arises from the examiner, whatever, that why you have preferred PLS instead of CBM instead. Why?
We're coming, like I said, we're coming. We are just there. Okay, the overwhelming popularity SEM has received in the last 1 decade is arguably unprecedented. Specifically, PLSM has become the most preferred data analysis technique amongst researchers for various fields, which advocates for PLSM being a silver bullet. Here, Ringelstad, these three names are actually, Sørsted actually, should be pronounced Sørsted. These three are the actually main, researchers, main scientists who have developed it, advanced it, and they're the touch barrier of it, right? If anything, if somebody writes anything against PLS-SEM, they're the first one to refute that. Right? There is one called Rethinking of PLS-SEM, and then they wrote Rethinking of Rethinking PLS-SEM, and they refuted altogether. That means there are many experts out there, there are many researchers out there, scientists out there who believe that PLS-SEM has some issues, and it should not be used in as much in mainstream research. Nonetheless, if you look at marketing, if you look at business, HR, if you look at information, psychology, you will probably find PLSM is the most used type of analysis, is the most preferred analysis now, right? However, some old school still exists. I know many journals, if you have used PLSM, they'll reject you for this very reason. They'll reject you right there. Right? They won't even care, how much contribution your paper is making. There are some old school, top mainstream journal. They'll reject you right there if you have just PLSM, right?
So what's the reasoning behind it?
Okay, like I said, old school. They believe PLSM has some inherent issues, and as a result, it's an inferior analysis than CBSM. They prefer CBSM. That means if you use CBSM, they're okay with that. That doesn't mean PLSM is weak. That doesn't mean PLSM we should not be using. It's just, there is always a conflict of interest. There is always conflict of opinion. They believe that CBSM is better. They don't like PLSM. Or they prefer PLSM if it starts from certain type of experiment. Let's say you have two very robust experiment and then you go to PLSM, they may consider it. You just go with PLSM, I know many journals, on slot, right away they reject you. They don't even consider what you have written. And they tell you actually, they say, well, methodology is not up to the mark. They won't say very specifically. If you want, I have one somewhere in my email. The guy, the editor gave me long detail and he gave me many citations that why you should not be using PLSM. Okay, that's his opinion. That's 10%, 90%, well, don't agree with him. They say, no, he's wrong.
They are also concerned regarding the population. When you have large population, then why do you prefer PLS? Why don't you go for the CBSM? So they also argue this, some these editors, they say like this. This also will be.
Well, like this gentleman said, there are clear difference between why we use PLSM and why we use CBSM. If we are the objective of research is to explore a new area, even a new type of relationship, a new context, you may go for exploratory. But if it's you just want to confirm something already, we also call it a replication study, or something type of relation that have been tested many times. There's nothing new in it. We call it confirmatory study. They say for confirmatory, CBSM is far better. There's no doubt about it. Yes, it is. PLSM, they say if it's a new area, or we also call it causal predictive modeling. Causal predictive modeling. Your purpose is to identify the causal relationship as well as to predict it. Then PLSM is far better. The approach is a variance-based. PLSM is a variance-based approach, and CBSM is a covariance-based. That means it divides variance into common and unique variance for each variable.
Also, it has all those features which are offering by Smart PLS. Then why Smart PLS? Like
the calculation is different. So if you look at my slide, the calculation is different. Look, approach accounts for total variance and then variance base, and then divides. CBSM divides variance into common and unique variance for each latent variable. This is the difference. You remember I told you there is a correlation, right? PLSM doesn't take correlation. If you know correlation, actually it is a covariance. PLSM doesn't take covariance. They believe that any predictor beside your 4 predictor, there's a 5th predictor. Between these 5 predictors, there's no need to test covariance. If you're testing covariance, actually that means you already know these variables move into certain direction together. If you know this knowledge, which essentially means you're not exploring a new area, you're actually confirming it. Then go to CBSM. This is the actual theory behind it, and I can refute it, but this is what I'm telling you the reason. We're doing structural quotient modeling from a two different perspective. As a result, our calculation is different. PLSM, variance based. CBSM, which is AMS, most common software, CBSM, that's a covariance based, right? Correlation is there actually. When we standardize, covariance, actually that becomes correlation. Assumption. PLSM, they don't need, we call known parametric. That means they don't have this idea that your distribution has to be normal. There has to be a normal distribution of data. They don't believe in it, and I will talk. Just imagine you are exploring a new area. If you're exploring a new area, why it has to be number one, we call normally distributed. The other thing is that when they calculate in PLSM, when they calculate, automatically what they try to normalize the data through their calculation, right? So they do something within the calculation which allows them to, even if you have non-normal data, they try to normalize it. While CBSM doesn't do it, because their theory is completely no. Their theory is that if it's already established fact, there is an already established fact A, and you want to check that same established fact in B environment, it should look like similar to A in terms of data distribution. So there should be normality. There should be normality to two different.
Evaluators use this point as
Against PLSM, remind me. I'll give you the answer. I'll help you with that. Right?
What should we say?
Remind. Okay, if you want to know right now. Okay. So if you understand the one is normal, theoretically it needs normal. The other one theoretically doesn't need normal. And keep in mind when they calculate, they actually try to normalize the data.
Most doesn't work with missing data.
Anything can work with missing data if you need to know the problem and if there is some solution to it. For example, PLSM, in Smart PLS we have a solution available, right? They just click it and it will take care of it automatically. Nonetheless, when you have too much missing data, obviously it puts a huge question on the validity of your results. Whether it is, because keep in mind when there is a missing data, you're doing some type of treatment for that. That treatment is not 100% right. That does not mimic exactly what the original answer would have been, which is missing right now.
CBN also issues, I think, model fitness. PLS we get a model fitness.
So her question is that one of the most common argument is that why have you, if your data is normal, why have you used PLSM? Because PLSM allows you to use non-normal data. It doesn't require. Number one, it allows. Why it allows? Because like I said, if you look at how they're calculating, they try to first step they do after weighted error, the first thing they do, they try to normalize it by dividing with variance or standard deviation. All right, they try to normalize it. The other thing is we need to understand is this, that PLSM, we don't use PLSM from this point of view because my data is normal, I'm using PLSM. This approach is very common in actually secondary data research in economics, very common. They run their analysis according to the type of data, right? If there's an issue with data, they'll go towards other, use strata and you'll be surprised for one type of data, hundreds of different type of solution it offers to you. You have this problem, use this test. You have this problem, use it. You cannot remember, you cannot memorize them. It's very difficult, hundreds of tests. We don't use PLSM. We use PLSM from the theory that we are going into a new area. We are trying to predict it. This is good enough reason. So if your data is a little bit skewed, and we'll talk about when you're skewed, it's good PLSM. Nonetheless, doesn't mean that if you have normally distributed data, you cannot use PLSM. You can. Why not? We're not using PLSM because our data is not normal. If this is the reason, that's a very weak argument actually. I personally think it's a very weak argument. Right? Okay, multivariate distribution, independent observation, parametric, asymmetric relationship between latent variable and its measure. Okay, so PLSM allows you to use both to measure both type reflective and formative, while CBSM is only reflective. Implication: optimal for prediction accuracy. Implication for CBSM is optimal for parameter accuracy. Like I said, parameter means you have already defined the population. You already define how this behavior will. Your results should give the similar result what you are expecting. That's about it. That's confirmation. Model complexity. They say PLSM can handle large complexity, such as even if you have 100 construct and even if you have 1,000 indicator, right? And in comparison, CBSM, they say you cannot handle much complexity. They say indicator should be less than 100 in any model if you want the reliable results, right? However, if you look at this, when you say large complexity, if you read some of the basic research, there's a concept called parsimony. It's against that. If you have that many, they say 100 up to 100 construct. This is against that parsimony, right? And I always remember this concept of parsimony from this concept. डॉक्टर साहब की इजाज़त से ही हो रहा है, उनकी इजाज़त से ही हमने फूड रिफ्रेशमेंट भी आज की है, तो प्लीज़ अप्रिशिएट कीजिएगा इसको. So parsimony, the concept of parsimony, that goes against that. It's like you go to a buffet, right? Buffet, and there are 20 different type of foods available. And after you have had your food, and somebody comes and asks you, tell me which food of the buffet, filled your stomach most. You cannot say that. It's very difficult to say. I've had 20. Let's say I've had 15. How do I know which one, filled my stomach most? I don't know. So the idea of parsimony is that the less रेहान साहब स्माइल करें क्योंकि ये बता सकते हैं इनमें क्वालिटी है.
You can just contribute here which food you like most.
आएगा नहीं, ये बता दूं मैं, इस उम्मीद पे ना रहना, आ जाएगा. Okay. So the less construct you have, the better argument you have. यानी एक variable, if you have in a variable, if you have, let's say 30 construct, it's very difficult, quantitatively or even theoretically, it's very difficult to say how much one has contributed to the other. The less construct, the better in terms of when it talks about theory building. But if you're talking about CBSM, it's fine. Why not? You can, because you already have theory available. You just need to confirm it. You don't have this problem. So if you want a specific contribution of one construct in exploratory study, better to have less construct. Less doesn't mean 2 or 3. I mean you should have 5, 6, 7. We can have no problem 8, but not up to 50 or 30. That would be probably against. Dr. Sir, कुछ कह रहे हैं?
Construct in terms of the conceptual framework or
the variables.
Variable. In terms of the conceptual framework that we have a
जी उसमें total कितने variables हैं?
How much you can limit us?
According to theory, ये तो कहते हैं कि जी 100 तक चले जाएं आप, कोई बात नहीं.
वो तो हमारे
मैंने इनको बताया कि पार्सिमनी का कॉन्सेप्ट है रिसर्च में, वो ये कहती है, स्पेशली पार्सिमनी का कॉन्सेप्ट तो नंबर 1 ये कहती है कि लेस कंस्ट्रक्ट होने चाहिए, इतने होने चाहिए जिसके बारे में कल जब आप प्रिडिक्ट करें तो वो बात हो भी. एक मॉडल में अगर 13 कंस्ट्रक्ट्स हैं, 13 या 14 कंस्ट्रक्ट्स हैं, वो ये कहते हैं कि एक्सप्लोरेटरी स्टडी के अंदर ये कोई बहुत, यानी आप कर सकते हैं, नहीं करना चाहिए, क्योंकि जब आपका ये आर्गुमेंट होगा कि यार ये कंस्ट्रक्ट ने इसने, कि वो कहेगा भाई 13 और हैं,
तो आप
12 और हैं.
कितने होने चाहिए मतलब?
अच्छा, इनसे पूछो. रेहान साहब, डॉक्टर साहब का सवाल है, जरा जवाब दीजिए.
मैं अपना बताऊं ना,
डॉक्टर साहब भी बता देंगे.
और ये अस्मा बैठी अभी बड़ी रेडी टू एबीडी बहुत इनसे पूछे ना कितने होने चाहिए. सॉरी मैंने आपके इंटरप्ट किया, लेकिन अभी एक पेपर पब्लिश हुआ है जर्नल ऑफ ऑर्गेनाइजेशन बिहेवियर में, दे ओनली हैव 4 वेरिएबल.
ये बहुत बड़ा जर्नल है जिसका ये नाम ले रहे हैं ना, इसमें छपवाना,
एक दोस्त है,
ये बहुत बड़ा जर्नल है.
डॉक्टर शिजाज जो है ना, मुझे बड़ी गालियाँ निकाल रहे होते हैं जब वो एनालिसिस कर रहे होते हैं, क्योंकि एनालिसिस गोज ऑलवेज टू हिम. तो मुझे अभी मैंने पेपर एक्सेप्ट हुआ है एक सोशल इन्फ्लुएंस थ्योरी में. अच्छा, थ्योरी के वेरिएबल है.
So sorry, we're quite ahead now, but it's mostly we haven't really tried software. Mostly we're trying to figure out what is happening here. Now, probably some of you know what is reflective, and probably some of you know what is formative. It's just two different way of measuring same or different constructs, right? We will talk about that. Just let me get that part. Okay. I can actually, let's start first PLSM and then we'll go there. Implication, okay, for prediction, okay. Now, lastly, sample size, right? So for exploratory study, it's better you have not more than 3 to 4 variable. Please don't have it. That's how the exploratory study looks like. But if you have like 10 variable going on, 5 variable going on, I'm not much hopeful for that. Take it. But sometime it may be published, sometime it may be accepted as exploratory. Often they feel that it's just taking away the focus when you add that many variable. You better be focused on one phenomena or two involving 2-3 variable. That creates a pretty situation for claiming your study is exploratory. Sample size based on the proportion of the model with the largest number of predicted 30. This is what the PLSM argument is. They say, the people who have done a simulation, they say even with as less as 100 response size or sample size, it predicts pretty well. In comparison, CBSM minimum you need 200. Even then, some people have argument of CBSM, which is Amos and other software. They said that it doesn't really perform. The bigger the sample size, the better it is for CBSM, right? Okay, so let's move forward. These are the softwares we see. Here, PLSM, Smart PLS is most common. Warp Plus is there. It's a very powerful software. R, we know R. R also have PLSM package now. You have to install it. Danco, it used to be quite popular before Smart PLS came. Then most softwares out there are for CBSM. Amos is on top. Literal, M+, SAS, R package for SEM, EQS, Yvonne, OpenX, and there are many more. There are many more out there. Okay, so here's the question: should I use CBSM or PLSM? Most important reason to select CBSM or PLSM is the research goal. That means the research objective. You need to know very clear what is your research objective. Whether you are interested in structure, that means confirmation, or you're interested in prediction. The primary purpose of PLS approach is the primary purpose of ML, which is maximum likelihood method, is referring to CBSM, is to study the structure of the observables. All right. The primary purpose of the PLS approach is to predict the indicator by means of component expansion. Right. In line with this notion, here 2011 recommend that if the goal is predicting key target construct or identifying the key driver construct, select PLSM. Right. If the goal is theory testing, theory confirmation, or comparison of alternative theories, select CBSM. If the research is exploratory or an extension of existing structural theory, select PLSM, right? And this, when they call causal predictive modeling, this allows you to use even, that's my humble opinion, even in many confirmation theories, you can use it. Your argument could be that I wish to see which variable predicts my dependent variable most. If this is your argument, okay, you can use PLSM. You have given them a good enough reason. According to theory, according to a book, you are doing the right thing. This is the reason they say, don't say exploratory, rather say causal predictive modeling. Causal predictive. Wherever you are you're concerned about causal relationship, wherever you're concerned about predicting, any endogenous, which means mediator or dependent variable, you can use it. No big deal. Okay, let's move forward. Okay, we have already talked about it a lot, so let's further. Okay, there are a few assumptions. Number one assumption, sample size. Second assumption, missing value. Third is distributed assumption, outliers, and unobservable heterogeneity. Let's talk about one by one. PLSM is good, like I said, for a small sample size, but that doesn't mean as small as you like. Better. There's two ways, there are two formula. One formula is that 10 times of the largest number of structural path directed at a particular construct in the structural model. Let me show you what do I mean by that. Okay. Now calculate here, can I take this pen and insert pointer? Okay, I can. Okay. You see this, can I see laser pointer? You see? Okay. So they're saying, what is the largest number? What is the largest number? 1, 2, 3, 4, 5, right? 5. They say 5. Right? There are only 5 paths in this model. And let's go back. 10 times the largest number of structural path directed at a particular construct. Okay, 10 times multiply. 5 into 10 is 50. according to the theory, minimum you need 50 responses, 50 subjects, 50 cases, however you want to say it, to get a reliable result. What do you call it? We call it statistical power, right? Statistically significant result. Other way around is you can use a free software called G-Power. Another way is just go to Daniel Soper and go to sample size and then select structural equation modeling. I wanted to show you, but I'll have to really get out of it. Okay, let's go here. Daniel Soper. Okay, my internet is not here. Give me a second. This Daniel Super calculator is very famous actually. Daniel Super. Yeah. Okay, this is Daniel Super. I go to this website. They have various other resources available to calculate it. Okay, so I come here directly a priori. A priori is usually before you conduct your research, all right? And anticipated effect size, it says effect size should be either 0.10. Let's put it 0.30 effect size. This is what we need. Desired structural level 0.80 should be minimum actually. Number of latent variable, let's say we have one latent variable, and here they say observe, which essentially they're referring to those items. How many items you have in total model. So let's say total model for all variable, let's say you have 60, right? Probability level is 0.05. This is significance level calculated. According to this, you need 154 minimum. Keep in mind this is minimum 154. Better have a couple of extra, probably 10 or 12. So later on, for any reason you have to remove the data, you're left with the minimum requirement. That's one. Okay, we'll talk about that at the end of it. Effect size is essentially how much you want each of this variable to make contribution to endogenous variable, which means mediator or the dependent variable, how much minimum impact they have. Sometimes, because this is another problem with regression, when you run the regression, you calculate R square value R 2.5, right? Well, it has the contribution of those variables as well who are actually contributing even 0 or 0.1. That's not even significant. You're still taking them as well. Effect size, what it does, it checks how much one variable predicts the other variable significantly enough. Right? F square. Right? We'll just go do that. We'll do that. Let me get through this and then we'll do pretty quick. Let's go back here. So, sample size. Number one thing, we need to take a look at sample size. Number two, missing values. It's very common to have missing value. They say for each indicator should be less than 5%. Because if each indicator you have even up to 5%, that will be like a lot. That will be like probably 5% of the total model. Yeah. So less than 5% is in case you have missing value. We have treatment in Smart PLS for that. This is what my aim of today's session is, to remain in Smart PLS, not to take help of SPSS, and let's see how many things we can take care of PLSM modeling without entering SPSS. Sometimes we are forced to, sometimes Smart PLS doesn't have those options. Okay, so even though I can go to SPSS, check my data for missing values, and I believe my data has 23 missing values. I tested last night, but I'm leaving them as it is because there is a solution available within Smart PLS. I'll use that one. Distribution assumption, normal distribution not required. That doesn't mean if you have it, it has any problem. It's just not required. But should not be highly skewed left or right. We'll take a look at what you mean by that. And then outliers. It's better to remove outliers. Outliers could put a huge question on the reliability and the validity of your data. Unfortunately, to date, I have no knowledge if there is any way to identify outlier within Smart PLS. We have to take Mahalanobis test. Just go to YouTube, Mahalanobis test, and you'll know how to do it. This is multivariate outlier test. Most common, very acceptable. You should do it. Very simple. It takes probably 5 minutes to do it, and you can do it within SPSS. It identifies your outlier. You just remove that particular row. Just remove that one, right? So because my aim is to remain in Smart PLS, I'm not going to SPSS. Otherwise, I could have done it. And unobservable heterogeneity, I will talk about that. It essentially means, unobservable heterogeneity means whether you have subgroups within your groups, right? Okay. Phimix is the option within Smart PLS. You can use it for this. Okay. If you have a probability sampling, if you have the probability sampling and non-probability sampling, I believe you all know that. So then this model, Kurgis and Morgan, this table is most useful. We should be sticking to it. But if we have non-probability, that which is the case, at least in marketing, HR, I know this is most common. A common phenomenon I'm investigating, how I'm going to bring what you call sampling framework, detail of each and every individual in my population, the population, study population. That's not possible for me. If that's the case, then go to that Daniel Super calculator or G-Power free software available. Otherwise, this is very common. If you know just two things you need. You just need to know the total size of your population here for probability sampling, and the other thing you need to have the sampling framework, right? And that's about it. If you have these two things, we can determine, for example, confidence level 95%. If your population size is above or at least up to 1 million, that should be 384. And even in many non-probability, many people take help, even if they don't have a sampling framework, they don't know the size of population. Many people use this as a baseline for their sample size. So we have both options. Daniel Super, I would recommend for anything actually, probability and non-probability. Other way around, if you really have sampling framework, you know the size of your population, then go for this probability sampling. Kurgis-Morgan table is very common, most accepted, very common way of it. Just to show you, because I knew some people may not know, on the left side you see positive skew, on the right side you see negative skew of the data, in the middle you see normal distribution systematically. Essentially, you can run PLSM in all these situations, whether your data looks like left, middle, or right. But if your data is slightly skewed or slightly, left or right skewed, no problem. But if your data is highly skewed, it is a problem. According to here, well, that put a huge question on the validity of result, because if data is highly skewed, they said don't use PLSM. Rather, take a look at, see if there's any way you can address that skewness in your data. Why there's so much high skewness in your data, because that could put question on the validity of your result. So slightly skewed is good. Highly skewed is not good for your results. Shouldn't be highly skewed. Okay. Again, outlier. Important to identify outliers. In these two graphs, you see scatter plot. Rather, you see the outlier very, very clear. And one I've identified, the other one I've not identified, but it's very clear that's an outlier. Outlier should be removed. If outlier is there, again, it could change the total variance of your, and as a result, could change the measurement, it could change the result, everything. Actually, it will have effect everywhere. Outlier should be removed, right? And for outlier, I've already told you, you need to have.
Do we need to tell why this was an outlier? Do we need to justify, or you just say that?
No.
Error in data hai ya, do we need to explain that or not?
As far as I know, PLSM, if you are running PLSM actually asks you to remove it. Don't ask you why you're removing. Just say simply remove. Wait, let me just finish it. So PLSM and writing paper, two different things. PLSM, okay. Now the new theory says, I know many, if you go to economists, they do not believe in outlier. I wouldn't agree with that, but again, your choice. If you're talking about paper, I don't think you should keep outlier. I guarantee you, if you say, well, I have to retain all the outlier, that's good enough reason to reject your paper. But the new economics theory says that retain everything, and they say, the argument is that in real life, you may have actually outlier. So that's still part of your population. So why are you removing it? This is the argument. Right. I wouldn't go with that. Again, it's very difficult because it changes the variance. It will change the variance completely. Put two outlier and you'll change the variance is completely different. Okay, but that's really your choice. If you think the editor is okay with that, then you retain it. I wouldn't retain it. I will never ever say that I've retained it. I will never do that. I have enough reason to get rejection. Why to create another one? Why to create another one? Okay. Then unobservable heterogeneity, with the concept is that do you have groups within your whatever. So let's say you have 300 people, and so what Femix does, Femix takes a look at whether these 300 people, can we identify 3 or 2 or even more groups within that they have completely different behavior. If that's the case, there is unobservable heterogeneity, and since structural equation modeling primarily uses the same methodology and similar way of calculation of regression, this is not recommended. You should not have heterogeneity. There is another called indigeneity I will not be talking about, which is actually correlation between unexplained variable and error and between prediction values. And then multicollinearity, you should not have it. VIF is the way we will be checking it. Then common method bias, also known CMV, or one way is we can use Herman single factor test in SPSS. Other way is full collinearity assessment. I'll be doing within PLS-SEM. So I'll be doing VIF in PLS-SEM, and I'll be doing full collinearity assessment in PLS-SEM to check my multicollinearity, and CMV, also called common method bias. Are we clear about this? Do we understand what is happening here? Because I met few, the people who actually decided not to come, and they were saying, oh, we don't know anything, so we need to know some of the basics. So I brought these basics here. On the left side, we see multiple regression, multiple mediator, predicting dependent variable. On top, we see mediation, where commitment is a mediating variable between cooperation and benefits. And then we see long-term orientation, which is a moderation between benefits and cooperation. We all understand the difference between moderation and mediation? Yes or no?
Yes.
Rehan Saab, since you're the most knowledgeable, what is the difference between these two?
The first assumption is wrong, so that's why I will not go to the second.
Which assumption is wrong? You are not Rehan Saab? I call you Rehan Saab. That was the first assumption.
The most knowledgeable.
That was the second one.
No.
That was the second one. Okay, essentially mediation refers to, just to remind you all, I believe you all know, mediation actually talks about the mechanism, that how these two variables are connected. Right? For example, I say, well, salary has a high correlation with the satisfaction or the happiness of employee. Well, that doesn't make any sense. Salary, well, it makes sense because as a salary, it increases their ability to buy more, pay more, take care of their needs, and as a result, it increases their happiness or satisfaction with the life and job. So this relationship between salary and the happiness is connected through their the life standard, their ability to improve or take care of their life. So there is a variable between these two variables which connects these. In comparison, when we talk about moderation, sir, कुछ कहना चाह रहे हैं? जी sir. Okay, I'm sorry.
This is also an initial assumption, or do we base it on a theory, or do we test it if it is either mediating or moderating, or can we change after the results? No, it's not mediating, it's moderating.
And if you change after the result, that's called spinning the data. That's called what we call manipulation. Don't do that. Theory drives modeling. Modeling doesn't drive theory. Let me just simply say. There are two theories. There are two perspectives. One perspective comes from statistics. The other comes from econometrics. Econometric believe the theory drives the modeling. Statistics say quite differently. Pure statistics say no, actually model, the data tells us, what is happening. We are somewhere in between. We believe data is important. Whenever you collect data, analyze it very, very closely before you run analysis. Descriptive analysis are extremely important. And I was talking to Madam other day. How many of us run EFA in any type of study? How many of us? Very few people. EFA, forget, even if you don't need EFA, EFA tells you what is happening there. How many of us check a standard deviation of our total, not the aggregated, each of our, we don't check that. Standard deviation tells me how much variance is there in each of them. If the standard deviation is low, obviously I'm not going to get good results. The higher the standard deviation, the better it is for me. Because it's a variance. If there is no variance in question, in answer, do you think I'll be able to explain anything? I'll be able to predict anything? Nothing. For example, I give somebody a questionnaire, and there are 5 constructs, and there are 5 items for each construct, and they keep checking 4, 4, 4, 4, 4. Throw it away. There is no variance in it. It's a type of response that's just taking place. just occupying a place. It has no variance in it. So variance is important. Now, so the idea is that whenever we collect data, we should be doing some preliminary checks. EFA just tells you what is happening, right? Standard deviation, mean values, just check. Scatter plot, just check what is happening. Scatter plot by each variable, individual. Scatter plot with two variables. Check what is happening. After that, when we'll run the analysis, I'll know what is happening, because I know already what is happening. I know which variable is going well, which variable has no correlation actually. I'll know very well. Then I will not be actually upset, this is wrong. I know exactly that's how my respondent have answered. And if I need to make correction, I need to make a correction there. Don't, but tamper with the whole data, for example. Don't try to change the whole data or collect the whole new sample. Rather, this is where the problem is. Most people have, made mistake with this concept, with this construct. Either they were not able to understand, or this is the novel finding. I was just unsure. Look what is happening here.
क्वेश्चन मैं जो काम कर रहा हूँ उसमें मैंने एक मॉडरेटिंग वेरिएबल रखा हुआ है, जो सर ने कहा कि अगर वो सेट नहीं हो रहा है इमीडिएटली, अब मैंने जब उसको मॉडरेट रखा है तो वो इनसिग्निफिकेंट आ रहा है। आई आल्सो नीड ए जस्टिफिकेशन क्यों आ रहा है एक तो अब अगर उसको मैं मॉडरेटिंग को अगर एज ए मीडिएटिंग कर रहा हूँ, क्योंकि इट इज वेरी फ्रेंडली यूजर, जब उसको मीडिएटिंग कर रहा हूँ तो वो सिग्निफिकेंट रिजल्ट आ रहे हैं। तो कैन यू डू दैट इन द रिजल्ट कि भाई मॉडरेटिंग के तो इफेक्ट आ रहा है, लेकिन जब मैं इसको इस तरह कर रहा हूँ तो ये आ रहा है दैट कैन बी कि इसको मीडिएटिंग कर तो ये इसको करनी चाहिए।
Let's put it this way. Let's say if I were you, I would dive back into theory and see, well, ठीक है, this wasn't the original intention of my theory, but probably I have identified something very novel and that I didn't know. I'll go back to theory, and can I argue that the many people have used it as a moderation, which is actually a mediation. And look, these are indication from the theory that could be a mediation as well, and then your study is fine. The originally, the data doesn't, in other words, data shouldn't be leading you, rather the logic and the theory should be leading you paper. ठीक है जी? Okay, so number means nothing. If there is no logic, number means nothing. Quantitative means nothing. Moderation actually essentially refers to the type of relationship we have between benefits and cooperation. For example, okay, what are the reasons for moderation? I'll just quickly say that because that's really beyond the scope of this my presentation. For example, benefit versus cooperation. Many people have used this relationship, and that has come out both negative and positive. And you believe that is happening because, according to it may be happening because there is some type of moderation available. There is some type of another force available that affects this total relationship, right? So then you use moderation. Other way around, in some cases, benefit cooperation have come out very, very weak. Some in other cases have come out very strong. Why there is a strong and weak relationship? There is some type of moderation happening. Yeah, that means the nature of the relationship and the strength of the relationship. We try to measure that through moderation. Can we? Probably benefits cooperation are negative in some other situation it's positive, just because of there is some moderator which is working in between. Yeah.
बेसिकली मॉडरेटर ही होता है जो दो वेरिएबल की रिलेशन को या तो स्ट्रेंथन करता है या फिर वीकन करता है।
बिल्कुल सही कहा। Let's start smart PLS. It's time to use smart PLS. Let's start it. Rehan sahab is extremely happy because do you have smart PLS on your laptop? You have it? Oh, okay. Let's see. Let us. Okay. Okay, so I would request all of you, please start your smart PLS. Okay, and I'm also starting my smart PLS, and I'll request all of you just make these 3 models with the data I've given you. So now we go here, very simple. So let's say I have 4 variable, whatever number of variable. Okay, let's first import the data. I go here. And then this is the data I've shared with you, right? Sample data. Can you do it?
Yes.
And then I open, as soon as I open, because you have a student version, so it will allow you, it will not allow you to run the data. You better bring it down to 100, sample 100, and then import it like this. And then I OK. As soon as I do that, look here, the indicators comes here. right? So now because I'm trying to mimic here, so how do I draw that? For example, I go here, simple select this refers to communication, these 5 items, right? And I just put it here. Oh, sorry, I'm sorry. Okay, so I come here and then select this, simply, there you go. I've created the first one. It will remain red until it is connected to a variable. Are you able to do, ma'am?
No, sir,
Ma'am?
I don't have indicator.
You don't have indicator? Why is that? Have you imported this file?
Yeah, it's there.
Oh, okay, ma'am, it will not show unless you create this, unless you go here, a new project. You have to create this, madam. Okay, let's say I'm not, okay. Look, as soon as I created a new project, this came automatically. I have to be here. And now, then it will show you the indicator. Can you do it? Is it okay, ma'am, now?
Yeah.
Are you able to do that? Just click. Okay, load slow. Okay.
How to select the indicators to bring?
Okay, let me do this again. So you know how did I create the project? Okay, how did I create the project?